Oh, you have a server.
Yeah, it's Raspberry Pi, Linux server. So I just have it running a Python
Why are you
script.
running Linux server? Just don't frustrate.
UK immigration service that give you the registration form when you first time enter the college. They will just click the headquarters or office in the center. They will just give you the registration form and you just come to the police station and that's ridiculous.
Yeah. Alright, so now I'm disappointed that my bot's not going to succeed.
So you have to ping it every 2 seconds to complete, and then you have to run another program as well that is going to fill your details and book the appointment.
Yeah, that's okay. I was more just testing it, but I detect when there were free appointments first.
It will make you to identify the picture.
Yeah, no, it's really
It's just like click. You don't
yeah,
have to
but it doesn't actually need that, I don't think. Like whatever way they designed their form, you can check the database without having to confirm the captcha. No, but it'd be very easy to block the box, but I don't know why they don't.
No, but the captcha that they're running. No, by the way, even if it goes out, the captcha that they're using is not the one with the pictures, it's just the one with the click. So you could write a program to do that.
No. Sometimes it prompts for pictures.
Yeah, but you can override it. I don't know, like not properly. Not done properly.
No, it's not implemented correctly. Yeah. Terrible. Alright, well then I'll have to think of something else though. Right, let's continue now. So, it's quite easy to start with this morning. We're going to have a look at trigonometry. So, like I said, very, very easy to start with. Okay, let's have a look. So before we start talking about sine, cos and tan, we have to talk a little bit about angles. So, how do we measure angle? Using what unit? Degree. So this would be 360 degrees. But there is a second unit that we could use to measure angles called radians. Yeah. And the way it works is that 360 degrees is the same thing as 2 pi radians. So that's like our first piece of information. So that means if you want like a shortcut, if you need to convert from degrees to radians, what you do is you multiply by pi over 180. And if you need to convert from radians to degrees, you multiply by 180 degrees over pi. Okay, can you just write this down now? I'm sure some of you have seen radians before. Huh? What's wrong with you, Amjad? What's wrong with you? Okay. Not for this part here. Okay, you got that? No. I'll give you a couple of examples just to practice. What I want you to do is to convert 330 degrees into radians, and then I also want you to convert 2.7 radians into degrees. Tell me what you get for each, please.
just give you the answer.
Yeah. So what's 330 degrees in radians? Should be around about 5.75 radians. And you used this guy, huh? And then 2.7 radians. What's that in degrees?
That is 154.6.
154.6. So 155 then. Okay. Yeah. So, I mean, like I said, there's hardly anything dramatic there. Okay. Now, next thing we're going to have a look at is something which you're all familiar with from middle school, and that's Pythagoras. Okay. Can I scroll down? Yep. I just like to write it in, but there's actually other symbols for radians, but I don't particularly like it. It's never used here. Does anyone know the symbol for radian? No, pi's not really the symbol. Pi's just a number. The symbol for radian. Does anyone know it? I write rad, but there is a symbol which I've seen used once in the exam, and it's a horrendous symbol. I think it's terrible. None of the maths teachers here use it. If you want to write 1 radian, you would write 1 and you write this symbol, which I think is terrible because it looks too close to degree. So you're only asking for trouble if you use that. You'll confuse yourself. So I much prefer just to write 1 rad like that. Okay. Next now, so Pythagoras. And we all know Pythagoras. Yeah. A squared plus b squared equals c squared. This is only true if it's a right angle, yeah. Right angle triangle. Now what is actually quite interesting is this is an example of if and only if. What I mean by that is, if the triangle is right angle, then it's true to say a squared plus b squared equals c squared. But also, if a squared plus b squared equals c squared, then you can say the triangle is right angle. So it actually goes both directions, which is quite interesting. So if you had a triangle and you know that this is true about it, then you know it must be right angle. So for example, I know the triangles with sides 5, 12 and 13 must make a right angle triangle because it obeys this formula. And I know the triangle with sides 1, 2 and 3 or whatever is not right angle because it doesn't obey this formula. It's actually quite a useful thing to remember that it goes in both directions here. Yeah. Okay so far? Yeah. So I'll give you I'll give you one to try. Give me the missing side here. Yeah. $24, yeah? Because you can say 10 squared plus b squared equals 26 squared. So b will end up being 24. Is that okay? Yeah? Can I scroll down? Yeah? Yeah? Okay. Okay. Will we prove Pythagoras' theorem? Why not? Okay. So we'll prove Pythagoras' theorem. Yeah. Why not? So the proof, if I remember, no. What am I doing? I know you don't care about the proof. And you're just going to ask me, do we need to know the proof? So. No, I will. We've loads of time. I'll prove it. It'll be good for you. Good for your general education. Right. So, okay. Let me just... Oh, it's already gone ugly. Sorry. I'm forgetting how to draw triangles and squares. 1 second. Square. You know what? I'm just going to get a picture because it'll be easier than me trying to draw it.
Or you could just skip all of it.
Huh?
Or you could just skip all of it.
No. I think, like I said, it'll be good for you. Oh, there's a beautiful picture. Right, let me try and copy that. Okay. Right. Whoa. Okay. Yep, steady. Easy does it. Good heavens. Right. That's supposed to be a square inside a square, by the way. Right. So, what I've done is I've put a square inside a square so that this length here is A, this length is A, this length is A. These small lengths are A, and this bigger length I'll call it B, 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 and B. Okay, and then I'll call this square, I'll say it has side C. So each of these are C's then. Okay, so let's see. You could look at it like you have this area of the square. So what's the area of this inside square here? C squared, yeah. Okay, so that area is there. And then you have the area of these 4 triangles. So what's that? So I want to get the total area. So it'll be C squared plus 4 times, let's just get the area of one of these triangles. So let's just say this triangle here. They're all the same. So what's that triangle's area?
N times C.
Yeah, a half B times A. Okay. Now, if I add the square and the 4 triangles, what area do I get? Well, that's the area of the whole thing, isn't it? Which is just one big square. So what's that area? A plus B squared. Because it's A plus B times A plus B. So, if I simplify this, let's see what I get. You won't be shocked. C squared plus 2AB equals A squared plus 2AB plus B squared. What can I cancel here? Yeah. C squared is A squared plus B squared. Okay, so like I said, it's good for you to see these things from time to time. Write it down. Got that? Can I scroll down? So the next thing we have to look at is something which, again, I think you're familiar with from middle school. Some definitions here. So, if I call this angle here theta, what's this side called? Yeah. And this side? And this side hypotenuse. Yeah? Yeah? Now, if you look at these three sides, there's comparisons, ratios you can make between the sides. How many ratios altogether can you make? It's actually 9, if you think about it, but not all of them are useful. So like, for example, you could compare the opposite to the hypotenuse, the adjacent to the hypotenuse to the hypotenuse, which is obviously, that's not a particularly useful one. You could also compare, let's see, the opposite to the adjacent, the hypotenuse to the adjacent, and the adjacent to the adjacent, which again, that's a kind of a pointless one. You could also look at, what have I not done? Hypotenuse over opposite, hypotenuse over hypotenuse, and what am I missing? Oh, sorry, I did that one, didn't I? Adjacent over opposite, and what one's left? Oh yeah, opposite over opposite. This is pointless then. So there's actually only 6 valid comparisons between sides that you can make, and 3 of them we'll study now and 3 of them in semester 2. So I think you know where this is going. We'll look at this ratio, we'll look at this ratio, and and this one here. These ratios are given names. This is called the sine of theta, which is written as sine theta. This one here is called the cosine of theta, which is written as cos theta. And this last one here is called tangent of theta, which is written as tan theta. And is anybody here from Vietnam? Because in some countries they write it TG theta. Does this look familiar to anyone? No? Okay. We write tan here. Okay, so if you can just make note of this. Oh, and there is a way to remember these. Sohcahtoa. Some people know this. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Yeah, what's wrong with it? Oh no, it's brilliant. Genius, yeah, it's genius. So, yeah, it's very common. Yeah. I mean, it's a perfect tattoo, you know, just Sohcahtoa. Enough said. Yeah. I don't have a Sohcahtoa tattoo. No. All right. If you write that down, we'll have a look at some examples now. Actually, maybe I'll call this lesson Sohcahtoa in the video. Doesn't seem right. Okay, can I scroll down? Yeah? Okay. So let's say this right angle triangle here. In this right angle triangle here, this side is 60. So, what's really nice about the sine, cos and tan, it's almost like your calculator can tell you from just the angle what the ratio is. Well, it can actually. So, if you were to type in sine 60 degrees, I know sine is opposite over hypotenuse. So I know your calculator will give you an answer of root 3 over 2. Yeah? It's almost like your calculator drew a right angle triangle with angle 60. I know if you type in cos 60, your calculator will give you an answer of 1 over 2.
You have to switch the degree.
Yes, and tan 60 will give you an answer of root 3 over 1. This is actually very useful because it means you can find missing sides. So I'll give you an example. So let's pretend that well, no, not something. Let's pretend you had this side here, and this side here, and you were looking for this. Now, can you use Pythagoras here? No, because you only have one side that you know. But if you look at it, you are looking at a way to relate the opposite and the adjacent. And you know one such way is tan. So you can say that tan 60 degrees should equal root 3 over x. But your calculator knows what tan 60 is. So you can actually say x is root 3 over tan 60. And that will give you an answer of 1.
Even though you don't have that, it's a right hand.
Oh, this is right. Yeah, sorry. This is right angle. Yeah, yeah. Okay. What's also not. Yeah.
When we take tan to the degree to the other side, is it supposed to be -2, -1?
No, that's what I'm going to do next. So if we want to look at finding angles, okay. So can I scroll down? Yeah. So let's say you had something like this. I don't know, 3, 4, and 5. And I want to know, let's say this angle here. Okay. So you can use sine, cos, or tan because you know the 3 sides. So let's keep it easy and use tan again, because we can look at relating the opposite with the adjacent. So you can say tan theta equals, what would it be here? 3 over 4. Or if you rather, tan theta equals 0.75. Yeah? Now, this is what your calculator can do. You want to ask your calculator basically this question. What angle do I need so that the tan of it is 0.75? And the calculator can do that by using a tan inverse function. So it can say, well, that angle is going to be tan inverse 0.75. So you're basically telling the calculator, give me the angle that will make a tan of 0.75. So if you put in tan inverse 0.75, what angle do you get? Like 53 or something, is it?
36.
Oh, 36.89 degrees then.
36.9. It's 36.86.
Okay, 36.9. Happy days. 36.9 degrees. Yeah. Now, 2 important things to say. This function is also called the arctan. It's the same thing as tan inverse. I actually prefer arctan. Huh? Say again? Ah, no, something else. Sorry, something else, yeah. That's next semester. I actually prefer saying arctan, but arctan's American. All the calculators here have it as this. Tan inverse, you know. I like the arctan because I actually think it's less confusing to use a different function than the -1. Because there's a very common mistake here. It's very common. And I'm going to say this, and yeah, but that's what I'm saying. But what I want to say here is this, okay, not this. Yeah, okay.
That's cosine.
That's cotan, yeah. So, for goodness sake, please don't make this mistake, okay? Don't do this. Don't do this. Tan inverse is not the same as 1 over tan. That's why I actually like using arctan, because you could never make that mistake, but your calculator doesn't display it as arctan, it displays it as tan inverse. So. No. It has nothing to do with 1 over. That's why I don't like this symbol here being used, because it makes students think it's like a power. It's actually not a power. This -1 has nothing to do with powers, unfortunately. It's just a symbol. It's as if they could have just done tan tick, like it's just a symbol, It's just the inverse of it. Yeah, so maybe they could have just even written as like inverse tan, like in tan, like that's all that's happening in tan, yeah, something like this. The I tan, yeah, I don't know. Okay, Continue now. So I want you to calculate this for me without the calculator. Cost of sine inverse of 5 over 13. See if you can figure this out without the calculator. Now tell me, is sine, okay, 5 over 13, is it a ratio or an angle? It's a ratio. Now 5 over 13 is a ratio, it's 5 over 13, okay? Sine inverse 5 over 13, is that a ratio or an angle? It's an angle. Cos of sine inverse 5 over 13, is that a ratio or an angle? It's a ratio. Yeah, because cos of an angle is adjacent over hypotenuse, okay? So, if we think about it like this, 5 over 13 is a ratio, and sine inverse of it is an angle. What angle is it? Well, it's the angle that you get when you have a triangle whose opposite is 5, and the hypotenuse is 13. What's this? That's 12. Okay, that's the angle. Now, we want cos of the angle. Is that a ratio or an angle? It's a ratio. What is cos of the angle in this question? Yeah, 12 over 13. So 12 over 13 is the answer. Now, if you type this in on your calculator, tell me, does it give you 12 over 13? Or does it give you a decimal? 12 over 13. Okay. So it gets a little bit harder now if I tell you to do this for me. I want you to give me cos sine inverse x. Okay, try this one now. Yep. Got it? Got it? Maybe. Let's have a look. So the trick here is to change this into cos sine inverse x over 1. And this is a triangle whose opposite is x and hypotenuse is 1. So its adjacent is... Yeah. And cos is adjacent over hypotenuse. So the answer here is root 1 minus x squared, like that. Yeah. Okay, have you got this written down? Not yet? Okay. Okay, got that?
What time was this at, by the way?
That one, the heck? 30.
Wait, so the
Oh.
way you got it, did you like do 8 squared plus
Mhm.
6 squared equals 1?
Yep. Yep.
And then you
Solve that one, yeah. Okay, I'll give you a few minutes to try some of these. You know, they're not too difficult. Should remind you of middle school. I think ABC in each should be fine. ABC. And the good news is the next lesson is also easy. So, easy morning for you. Normal enough, yeah, fraction, yeah. I can close this?